Hi, welcome back to Robust Statistics Workshop. Today we're going to be talking about outliers. My name is Sean, and I'm a statistical consultant in the McArdle GC3 lab at USC. So, what are outliers? So the definition of outliers is unusually large or small values. And let's take a look at how those outliers affect in your regression results. So if you take a look at figures 1, each figure has two lines, the red line and the blue line. And if you closely look at blue lines, they fit much better. They follow much better trend of the most of the data. And the red lines are not so much reliable. So the red lines are the fitted lines with the outliers, and the outliers are in the red boxes in the figures. And the blue lines are basically the fitted regression line after we take care of the outliers. So how do outliers affect your analysis? Let's bring the same example from chapter 0. Data 1 has 3, 3, 4, 5, 7, 10, and data 2 has 3, 3, 4, 5, 7, and 1,000. Now we know that 1,000 in sample 2 is an outlier. That made the mean and the standard deviation unreliable, basically meaningless, which means the mean and the standard deviation are not robust to outliers. Moreover, the mean and the standard deviation can go significantly wrong with just one outlier. So I think it's a pretty good time to introduce a new concept, a breakdown point, or formally, finite sample breakdown point. Breakdown point is one way of quantifying the sensitivity of a measure to outliers. It's basically minimum proportion of values that must be altered to make a measure arbitrarily large or small. Basically, minimum proportion of values that make a measure unreliable or meaningless. So the breakdown point of sample mean, and sample variance, and sample standard deviation is 1 over n, which means if you have n samples in your data, if you have n samples, and by just altering one of them can make the sample mean and sample variance and sample standard deviation go wrong. Just by altering one sample, your sample mean and sample standard deviation can be unreliable. And let's talk about the median. Median has the breakdown point of 0.5, which means in order for the median to be unreliable, you need to alter at least 50% of your samples. So we're going to say the median is robust to outliers. And what about interquartile range, IQR? The IQR's breakdown point is 0.25, which means in order for IQR to be unreliable, you need to alter 25% of your data, of your samples. And gamma trimmed Windsorized mean and variance. I know we haven't covered trimming and Windsorization. And spoiler alert, we're gonna cover trimming and Windsorization in the next chapter, section 1.2, how to deal with outliers. So gamma trimming and gamma Windsorization breakdown point is gamma. So let's say 20% trimming, 20% Windsorization will give you 0.2 of breakdown point. So based on the breakdown points, let's talk about the measures. So it's a different sample now. There are There are 5 2s, 4 3s, and 3 4s, and then 1 10,000. So obviously that 10,000 is now our outlier. And obviously the mean is 771, and the standard deviation is 2,772. And obviously, because we already know that the sample mean and the sample standard deviation have breakdown points of 1 over n, and because we already altered one value to a arbitrarily large one, now the mean and the standard deviation are unreliable, basically useless. But let's talk about those robust measures: mean, trimmed mean, and Windsor standard deviation. So median. So the median is still 3. And we already know that the median has a breakdown point of 0.5, which means just altering one value is not going to affect the median. And 20% trimmed mean, 20% trimmed mean looks even more reliable. It's 2.89 because it's 20% trimmed. 20% trimmed means this breakdown point is 0.2. 20% Windsor standard deviation is 0.86. So compared to the sample standard deviation, 2,772, and 20% Windsor standard deviation, 0.86, 20% Windsor standard deviation looks a lot more reliable. Then let's talk about how to detect those outliers. We're going to talk about 3 outlier detection methods. There are a lot out there, but we're only going to cover 3 in this workshop. First one is based on the mean and the variance, and it's not even worth knowing because we already know that the mean and the variance are not robust. So if you have one outlier in your sample, then the mean and the variance are already unreliable. And are you really gonna trust the method that uses unreliable, not so much robust measures? I don't think so. So we're gonna skip the first method. And the second method is mad median rule. So mad median rule uses median, and the median has breakdown point of 0.5. So the mad median rule has breakdown point of 0.5. And the box plot rule. The box plot rule uses IQR. So the IQR has the breakdown point of 0.25. So the box plot rule also has the breakdown point of 0.25. And let's talk about outliers from distribution's point of view. So outliers lie in the tails of a sample distribution. If you think about the definition of an outlier, unusually small or large value, they obviously sit in the tails of your sample distribution, which means if you have heavy-tailed or even skewed distribution, then you have higher probability of getting outliers in your samples. Let's take a look at figure 2. So the dotted curve is the standard normal distribution with the mean 0 and variance 1. And the solid curve is heavy-tailed non-normal curve. The solid curve is mixed normal distribution with a mean 0 and variance 10.9. And because it is heavy-tailed by meaning that the tails are above the normal distribution, because it is heavy-tailed, if you have heavy-tailed distribution, then you have higher probability of outliers in your sample. So in section 1.1 today, we covered how to detect outliers, what they mean in terms of your sample distribution. And in the next chapter, section 1.2, we're going to talk about how to deal with those outliers and why you can't just remove them. And also, we're going to talk about trimming and Windsorization. Thank you very much.